Hello, and welcome to this video, which is part of the Sitecore Experience Commerce Deep Dive series. In this video, we're going to focus on the architecture entities created as part of a Sitecore Experience Commerce deployment. We're going to start by discussing how single and multi-tenancy setups are created in Sitecore Experience Commerce. Then we'll go over the concepts of policies, environments, rules, and bootstrapping, and how they are used to configure your deployed system. After this, we'll then look at the various architecture entities themselves and how they form a completed deployment. We'll follow this by going through some sample data flow scenarios to demonstrate how and when the different architecture entities communicate with each other. Then finally, we'll finish off by looking at some example topologies, showing you how you can scale the various architecture entities. So let's start by seeing how Sitecore Experience Commerce enables you to handle single and multi-tenancy scenarios with ease. Sitecore Experience Commerce 9 is configured for both single and multi-tenancy out of the box. With a single tenancy setup, you have a single storefront being served out of your Sitecore content delivery instance. And this storefront will make calls through to the commerce engine, accessing the configured shops environment and the policies that it contains. With a multi-tenancy setup, your Sitecore content delivery instance will house multiple storefronts, and your engine will host multiple shops environments. Each storefront will communicate with its own shops environment. Each shops environment will in turn house its own set of policies governing how it functions. This means that you can have a single Sitecore content delivery instance and a single Sitecore commerce engine hosting X amount of sites, each with completely bespoke functionality, not only in the storefront, but also in the engine. This enables you to deliver highly customized functionality per storefront. So now we can start to take a look at how a deployment of Sitecore Experience Commerce is configured. We'll start with policies. A policy can be thought of as a group of settings that affect the functionality of a feature within the commerce engine. They're named, versionable, variable datasets that go towards making the engine as configurable as it is. They're all stored in a centralized policy store, which is populated via the Bootstrap functionality we'll talk about in a minute. And they're heavily cached, rarely changing their values outside of a deployment scenario. A commerce environment can be thought of as a collection of policies that affect how a call to the engine is executed. They give the ability to have separate service functionality hosted in a single service instance. Typically, all of the environment's configuration is stored in a single persistent store. However, they can be separated out if required. This means that you can have the same call to the engine function very differently depending on which environment variable is specified. For example, if you request a product's details using the shops environment, you'd probably read the data from a cache to improve the performance. Whereas if you passed in the authoring environment instead, you'd most likely pull the data directly from the database to make sure it was the most recent. Next, we'll look at roles. So a role is a deployed instance of the commerce engine. In a development environment, you'll typically only have a single instance of the engine deployed on your system that will serve requests for all of the roles and environments you have configured. However, in production, these are usually split out into separate instances to allow you to scale each one to specifically match the load you see on your site. The distinction between roles is purely logical though. There is no real difference in the files that are actually deployed. A role is instead defined by where its traffic originates from. The final configuration piece we're going to talk about is bootstrapping. Bootstrapping is the process of reading the policy and environment data from JSON files on disk and pushing them into the global policy store for the other engine instances to be able to access. This is completed by the Bootstrap pipeline, which loads the environment configurations from the environments folder into the global database. After bootstrapping, those environment JSON files no longer need to be present, as for all following calls, the environment configuration is retrieved directly from the database. So let's take a look at each of the architecture entities that come together to make up a Sitecore Experience Commerce deployment. Here you can see all of the architecture elements needed for an XC deployment. Note that you will also need the various XP elements, but those are outside the scope of this video. Details of those elements can be seen in the various XP architecture videos. So for Sitecore Experience Commerce, you have two databases called Global and Shared Environments. You have 4 different engine roles: your shops, authoring, DevOps, and minions roles. You have 3 indexes: your catalog item scope, your orders scope, and your customer scope. And finally, you have the 2 elements that are used for the business tools: BizFx and the identity server. The Shared Environments database is the main data store for a Sitecore Experience Commerce deployment. This stores all of the commerce data used on the site. For example, catalog data, customer records, pricing information, any promotions that have been configured, along with all the generic entities and lists that power the functionality created in the various plugins that are installed. The Commerce Global Database is used to store all of the global configuration data that governs how the engine roles function. This is the database that stores all of the environment and policy data when you execute the Bootstrap functionality we mentioned earlier. This is where all the JSON configuration finally ends up. The shops role is the instance of the commerce engine that serves traffic from one or more storefronts. In both the single and multi-tenancy examples we saw at the start, all of the various storefronts were all communicating with their respective shops roles. This role is intended to scale to support demand and is usually installed in close proximity to the storefront instances that generate the traffic. The authoring role. This is the instance of the commerce engine that serves traffic for the commerce business tools, BizFx. Since this role serves lighter traffic, typically just requests from the merchandising tools, its scale requirements are normally relatively low. The minions role is an instance of the commerce engine that runs independently and supports asynchronous processing. This is designed for post-order capture processing as well as any cleanup or pruning. It is typically set up as a worker role, not a web role, as usually doesn't actually receive any web traffic. And the role contains a series of minions, each one with a specific task. For example, the pending orders minion, which is used to process the pending orders queue. Now within the minions role, you can actually horizontally scale each of the individual minions it hosts through the use of a minion boss. A minion boss is used to allow multiple instances of the same minion to run within the minion role. This means that if you have a large number of orders that need to be processed, you can actually create a minions boss to stand up multiple instances of the pending orders minion. That means you can have multiple minions processing the pending orders queue at the same time, allowing the queue to be processed a lot faster. The DevOps role is an instance of the commerce engine that is internal and only really available to DevOps personnel. The role typically has an identity with higher privileges, allowing DevOps personnel to perform maintenance tasks that are not permitted to other roles. For example, bootstrapping and environment initialization function. The BizFx tools are the brand new merchandising interface for Sitecore Experience Commerce. This has been built from the ground up using the latest development technologies. It's built using Angular 4 and is completely extendable through the plugin architecture. This allows you to customize the experience for your merchandisers and your customer service representatives. The identity server is a federated authentication provider for Sitecore Experience Commerce. This is used to authenticate calls through to the engine and also access to the BizFx merchandising tools. Finally, we come to the 3 indexes that are part of Sitecore Experience Commerce. They are all used to power the search features within the BizFx tools. You have the orders scope index, which allows merchandisers to be able to search for a specific order and quickly retrieve its details. You have the catalog items scope index. This is used to allow merchandisers to be able to search for specific catalog items. And you also have the customer scope index. Again, allows merchandisers to be able to search, but this time for customers. So that's given you a quick overview of the different elements that form a Sitecore Experience Commerce installation. But now let's look into some common data flows so you can see how each of the elements interact in common scenarios and how they will be scaled to handle certain load scenarios. First off, we're going to take a look at how the different elements interact when users browse the catalog. When a shopper is viewing one or more sellable items on a site, the user hits the SXA storefront page containing the catalog data, for example, a product listing or product detail page, and the rendering details are loaded from the Sitecore web database. This then uses the Sitecore web index to get details of the sellable items. The index documents are converted into Sitecore items, and the commerce data provider makes a call through to the shops role. The shops role retrieves the sellable items from the catalog entities table in the shared environments database, and the price is calculated using data from the pricing entities table, again in the shared environments database. The found sellable items are returned back to the content delivery instance. The data is then rendered and returned to the browser for the user. When a shopper is adding a sellable item to their cart, the user hits the SXA storefront page containing the add to cart rendering. The rendering details are loaded from the Sitecore web database, and the rendering uses the Sitecore web index to get the details of the product. The index documents are then converted into Sitecore items, at which point the catalog data provider takes over and calls through to the shops role. The shops role retrieves the sellable item entity from the catalog entities table in the shared environments database, and the found product is returned back to the storefront. The user then clicks on the Add to Cart button, and this executes a controller action, again that calls through to the shops role. The shops engine instance retrieves the cart from the commerce entities table in the shared environments database, and retrieves the sellable item once more from the catalog entities table, again in the shared environments database. A new cart line object is created, and the shops engine updates the cart to include this new cart line object. The shops engine persists the cart back to the database, and finally, the cart is returned back to the storefront and the updated data is displayed to the user. So how would this work in a load scenario? Let's say you have a site with a large number of cart transactions. As mentioned previously, the cart data is stored in the shared environments database. So sites with large amounts of cart activities will place load on the storefront CD instance, the shops role, and the shared environments database. Now we've gone through data flows for browsing the catalog, let's take a look at some that form the typical actions executed during checkout. Here we're assuming the user already has items in their cart and has navigated to the checkout page to enter their shipping details. Again, the rendering details are loaded from the Sitecore web database, and the shipping configuration data is taken from the control panel stored again in the Sitecore web database. Shipping data itself is retrieved from the shops role, and this data is pulled from the commerce entities table in the shared environments database. The user selects their shipping type, enters their shipping details. The data is then pushed back to the shops role. This is stored against the cart in the commerce entities table in the shared environments database. Next, the user is going to progress to entering their billing and payment details. Once more, the rendering details are loaded from the Sitecore web database using the Sitecore web index. The user then enters their email address and their payment details, which are validated against a third-party payment provider. The example provided out of the box is integrated with Braintree. Finally, the payment token is stored against the cart. The user then enters their billing address, clicks Next, and the billing information is stored against the cart again in the shared environments database. The final step in the checkout process is where the user confirms their order and completes the checkout as a whole. Again, the confirmation page rendering details are loaded from the Sitecore web database using the Sitecore web index. The user then hits the confirm button to complete the transaction, and the request is made through to the shops role. The payment is confirmed with the third-party payment provider. The cart is converted into an order with a pending state and stored in the order entities table in the shared environments database. The sellable item inventory is updated to be reduced by the purchase quantity and again stored in the shared environments database. Also, an entity index entity is persisted to the shared environments database, which will queue up an update for the order scope index, and that will be performed by a minion. Finally, the order is added to the pending orders list. So that covers the standard data flows for the checkout process. But for a load scenario, what architecture elements would be affected by sites which handle large amounts of orders? Well, sites with large amounts of orders, we'll see load being placed on the following entities: the SXA storefront content delivery instances, the shops role and the shared environments database, but also on the minions role and the orders scope index, as that's responsible for processing the orders once they are created with their pending state. So now we've been through the catalog interaction data flows, let's take a look at some common user activities that will take place on your site. When a user registers and creates an account on your site, the user will load the registration page. As with before, the rendering details are loaded from the web database using the Sitecore web index. The user then completes the form and hits the submit button. This sends a request to the shops role to create the user, and a new customer record is created in the commerce entities table of the shared environments database. An entity index entity is persisted to the shared environments database, which queues up an update for the orders scope index to be performed by a minion. And finally, the user record is created in the ASP.NET membership tables in the Sitecore core database. Now, what happens when the same user returns at a later date and wants to view the previous orders they placed on the site? The user will bring up the login form, enter their details and submit it, and their credentials are validated against the ASP.NET membership tables in the Sitecore core database. The user is then logged in and navigates the account management page. The renderings are loaded from the web database using the Sitecore web index, and the recent orderings rendering makes a call through to the shops role. The data is read from the customer orders list stored in the shared environments database, and this retrieves a list of orders for the logged in customer. The details are then retrieved from the order entities table and displayed back to the user. So, as with previous diagrams, how does a large amount of load affect this? Well, a site with a large amount of customer registrations would experience load on the following architecture entities: their SXA storefront content delivery instances, the Sitecore core database, the shops and minion roles, the shared environments database, and also the customer scope index. So you'd have to scale those out to match the load as required. So now we've covered a lot of the most common shopper activities. Let's take a look at the common merchandiser activities that take place. So what happens when a merchandiser is managing items in the catalog? Well, initially the merchandiser will log into the BizFx site. Here the user credentials are validated using the identity server, and the credentials are checked against the data stored in the ASP.NET membership tables in the Sitecore core database. After they've been authenticated, the BizFx tools then call through to the authoring role to populate the UI. The merchandiser navigates to the merchandising dashboard, and a call is made to the authoring role to get the catalog data from the shared environments database. The sellable item is selected, and its details are returned back to the user. The merchandiser then updates the details as required and hits the save button. A call is finally made through to the authoring role, and the updated sellable item is persisted into the shared environments database. Finally, an entity index entity is persisted to the shared environments database, which will queue up an update of the catalog item scope index to be performed by a minion. But now let's take a look at what happens when a customer service rep places an order on hold. First of all, the rep loads up the BizFx UI and navigates to the orders dashboard to search for an order ID. Here, a request is sent through to the authoring role, which searches for the order using the order scope index, and the data is displayed back to the user. The user then selects to place an order on hold, and the request is sent through to the authoring role to action this. The order is updated to have a state of on hold and is persisted back to the order entities table in the shared environments database. It is also added to the on hold orders list and removed from the pending orders list, both stored in the orders list table in the shared environments database. And finally, as with before, an entity index entity is persisted to the environments database, which will queue up an update of the orders scope index to be performed by a minion. Looking at the load scenario for merchandising activities, how would a site with a large amount of catalog items, or say a site with frequently changing catalog items, need to be scaled? In this scenario, your site would experience load on the following entities: the Sitecore content management instance, the web index, the shopfront minions roles, the shared environments database, and the catalog items scope index. So you'd have to scale these entities to match the load that you're seeing. The final set of data flow diagrams we're going to look at are some of the common minion and DevOps activities that will be performed. So I mentioned before about the pending orders minion. Let's take a look at how that interacts with the various architecture elements. The minions role begins the process by retrieving the next pending order from the pending orders list stored in the order list table in the shared environments database. It ensures the order is in its correct state. It then finalizes and closes the sale with a third-party payment provider, and then generates the sales activity record in the commerce entities table in the shared environments database. It will update the order to be in the release state and persist it. And finally, an entity index entity is then persisted to the shared environments database, which will queue up an update of the order's scope index to be performed by a minion. Another of the minions actions we've mentioned is updating one of the records in the 3 different indexes. Here, the minion role gets the next entity index entity from the shared environments database, pulls the required data, and finally updates either the catalog items, orders, or customer indexes as appropriate. At the start of this video, we talked about the concept of bootstrapping, so let's take a look at how that process interacts with the different entities. Here, the DevOps user loads up Postman and selects the bootstrap command from the DevOps collection. They execute the command, and this is sent through to the DevOps role. The configuration data is then read from the files on disk, and the environment and policy data contained is stored in the global database. A result message is returned back to the user. Another task that can be performed by the DevOps user is to initiate a rebuild of the indexes we've mentioned. In this example, we're going to see how initiating a rebuild of the order's scope indexes are performed. The DevOps user loads up Postman once more, this time selecting the run full index minion orders command from the DevOps collection. They execute this command and the request is sent through to the DevOps role. The order information is read from the shared environments database, and the order scope index is updated as appropriate. Again, a result message is returned back to the user. So we've covered a good amount of data flow examples that should have given you an understanding of how, when, and why each of the different architecture entities interact. But now let's take a look at some example topologies so you can see how these elements might be deployed in different scenarios. Here, in this first example, you can see a typical minimally scaled instance. Now you'll hopefully never see a production instance set up this way, but this will be very typical of a developer machine. Here you have a single machine with all of the architecture entities installed on it. You can see all of the databases, indexes, and business tool elements are present. And one of the interesting things here is that all of the engine roles have been condensed down to a single engine instance. Now this is the simplest architecture that you can create for Sitecore Experience Commerce, and while that would be fine for a developer's setup, you likely wouldn't see this topology in use anywhere else. So let's start to scale this out. Now we're still here looking at a single machine used for all elements, so this is an alternative developer machine configuration, or a scaled developer machine configuration might be a more appropriate name for it. This is very similar to the developer setup seen on the previous page. However, now we've scaled out the different engine roles to their own instances. This gives the advantage that it would more closely match a production environment, giving the developer the confidence that they won't run into any architectural-based issues as they've been developing against a configuration that more closely matches their target production state. Now in this example, we've moved away from the developer machine concept. Here we still have the various engine roles, indexes, and business tool elements running on a single instance. However, we've now moved the databases off to be hosted on a separate machine. This would commonly be seen on a small, low-traffic test server. Here we've started to scale out the topology more. Now we've moved the indexes off onto their own server. This means that you can individually scale the resources used by the indexes, databases, and the web instances as a whole. Carrying on scaling out this architecture, Here you can see the dedicated database and indexing resources introduced previously. We've now also separated out the business tools from the engine instances. This means that you can vertically scale the engine instances or the business tools individually to correctly handle the load as required. Continuing down this path, you can see how now each of the engine roles have also been pushed out to their own instances. This gives you the ability to individually scale each of the engine roles as required. For example, if you have a storefront with a large amount of traffic, then you can scale the shops role to handle more traffic than the others. Another example would be a site where you have a large number of merchandisers making a large number of frequent changes. This architecture would then give you the ability to scale out the authoring role to be able to handle the load there. And here you can see the final topology example we have. You can see all of the different entities have now been moved into their own instances, allowing you a really fine-grained control over the scaling settings for each. So as you can see from these different examples, there's a great deal of flexibility available in the way that you can deploy Sitecore Experience Commerce, allowing you to truly tailor your deployments to match your specific needs. Hopefully this video has given you a good overview of the different architecture elements involved in a Sitecore Experience Commerce deployment. You should also have a grasp on when each of the different entities communicate with each other during common data flow scenarios. Finally, we walked through the different scaling scenarios and showed the flexibility that Sitecore Experience Commerce offers for your deployments. For further information, you should view the rest of this deep dive series on our master YouTube site. You can see our documentation on Experience Commerce on our developer and documentation sites. And finally, you can also ask any questions on our community site. Thanks for watching.